Okay, so for this problem, we want to convert this to polar, Cartesian, polar, and trig form. Is that what I'm doing? Yes. So the first thing that I'm going to do is, oops, not that one. Um, the first thing that I'm going to do is see if I can fix this so that it's in Cartesian form. Cartesian form, so whenever we're talking about Cartesian form, it's literally of the form a plus bi. Okay. And if you look at this, technically, it's not, but it really is. So I'm just going to simplify this problem and then I'm going to write it in the form of a plus bi. Does anybody see anything that you could do with this problem? Does anybody see anything that you can do with this problem? What could we do? What's the first thing that you see that we can do this with this problem to simplify it? Very good. Those negative threes, they cancel. So I'm going to go goodbye negative 3, goodbye negative 3, and I'm just left with root 3i. So depending on your teacher's preference, root 3i is of the form of Cartesian just because a is 0. But just to make it obvious for you all, I'm just going to write it like this: 0 plus root 3i. Does everybody see how everything kind of like matches up? That is what Cartesian form is. So now we're looking for polar form and trig form. Polar form is of the form r comma theta. And then trig form, I'll write next to it, is of the form r cosine theta plus I sine theta. And to me, this makes sense like the trig form because cosine is your x. It usually is your x value and sine is your y value when you're dealing within the unit circle. So that's why that makes sense to me. And then we're multiplying it, we're scaling it, we're dilating that circle bigger by multiplying it by r. So this makes sense to me. So the next thing I'm going to do is I'm going to figure out how to get from Cartesian to polar and then to trig. So notice from polar to trig, there's not much work happening because you're just literally plugging in your r and your theta into that trig form. So the real work is going to go from Cartesian to polar. So the first thing that you're going to do when you're going from Cartesian to polar is you're going to graph your point. Okay. You're going to graph this point, which is 0 plus root 3i. Remember that this is your real axis and this is your imaginary axis. And you just graph it as if they gave you x comma y, except here they're giving you a plus b I. So a in this case is your x. So that's 0. So go nowhere left and right, right? Go 0. And then it says go up root 3. So this is my point. 0 plus root 3i. Does that make sense? So when we're doing this, now we're going to build our polar. And when you're building polar, normally you have a triangle, but whenever it lands on the axes, it confuses students because you're like, Ms. Johnson, there's no triangle. But this one actually, there's less work for because you do not have to build your triangle, right? So when I'm looking for this, I'm looking for my radius 1, and your radius is, if you can imagine like me building a circle. Hey, that was pretty good, right? And then what would the radius of that circle be? What would the radius of that circle be? How, like from here to here, how long is that radius? Anybody? Yeah, perfect. Square root of 3. How did you know that, Miss Johnson? Because when we started at 0, when I graphed that point, I went up root 3. So this length here is root 3, right? So that indicates that is my radius. Everybody okay with my radius? Your radius is just the length of the radius most of the time it looks like your hypotenuse. Your hypotenuse is your radius. But Miss Johnson, I don't have a right triangle. Yes. So then your radius is just how far you go up or right, because you're on an axis, right? You're on one of the axes. Okay, so then how would I find the theta? What angle is this? What angle would you call this? From here to here, what angle is that? What angle is that? Yeah, it's pi over 2. How do we know it's pi over 2? Well, because this is 0, this is pi, so this is pi over 2. Anybody remember the guy down there? What's his name? This guy down, all the way down here. What's his name? Yep, 3 pi over 2. Very good. Okay. So now that I have my r and my theta, then I'm going to come over here and I'm just going to fill in these blanks here. So my structure is cosine something plus I sine something. And then I'm just going to plop my r and my theta in there, and then I'm done. So my r that you guys found was root 3. My theta that you guys found was pi over 2. And I'm done. All right, what questions do you have for me here? This is like one of those special case ones that's a little bit confusing because normally you guys are used to looking for the radius because he has a hypotenuse, and then you use the angle because we've referenced some 30, 60, 90, or 45, 45, 90 triangle kind of thing. So again, I'm going to walk you through. Number one, you're going to do whatever operation they tell you to do, which in this case it was division. And then you have your Cartesian form. Make sure it's of the form of a plus bi. Then over here, you're going to graph that point on the complex plane, remembering, like in your mind, in my mind, I'm like, oh, you're x and you're y. Instead of x comma y, they gave it to me of the form of a plus bi, and that's, you graph it exactly the same. So I'm really asking you to reach back into like 6th grade, 7th grade, 4th grade, 5th grade, and really remember how to graph those. Okay, once you have that, then you are looking at the radius, which in this case was how far you went up. Okay. Sometimes when your point looks more like this, like pretend that you're, I don't know, it was here, right? Then your radius is your hypotenuse, right? And your theta is whatever got you there. So it's still the same. But in this case, it's kind of like a special case that confuses students because they're like, where's my hypotenuse? And in this case, you're really looking for how far you went up or over. And then once you have your polar form, it's literally just plugging in to get to your trig form. So you should be pretty strong in that. Okay. All right. Thank you for listening.